Scanning Electron Microscopy Lecture 2, Dr. Abu Al-Hassan Faiz. A scanning electron microscope, SEM, scans a focused electron beam over a surface to create an image. The electrons in the beam interact with the sample, producing various signals that can be used to obtain information about the surface topography and composition. Principle of working scanning electron microscope. Source of electrons. Column down which electrons travel with electromagnetic lenses. Electron detector. Sample chamber. Computer and display to view the images. Electrons are produced at the top of the column, accelerated down and passed through a combination of lenses and apertures to produce a focused beam of electrons which hits the surface of the sample. The sample is mounted on a stage in the chamber area and, unless the microscope is designed to operate at low vacuums, both the column and the chamber are evacuated by a combination of pumps. The level of the vacuum will depend on the design of the microscope. Schematic of a scanning electron microscope. The position of the electron beam on the sample is controlled by scan coils situated above the objective lens. These coils allow the beam to be scanned over the surface of the sample. This beam rastering or scanning, as the name of the microscope suggests, enables information about a defined area on the sample to be collected. As a result of the electron-sample interaction, a number of signals are produced. These signals are then detected by appropriate detectors. Sample-electron interaction. The scanning electron microscope, SEM, produces images by scanning the sample with a high-energy beam of electrons. As the electrons interact with the sample, they produce secondary electrons, backscattered electrons, and characteristic X-rays. These signals are collected by one or more detectors to form images which are then displayed on the computer screen. When the electron beam hits the surface of the sample, it penetrates the sample to a depth of a few microns, depending on the accelerating voltage and the density of the sample. Many signals, like secondary electrons and X-rays, are produced as a result of this interaction inside the sample. Electron beam interaction schematic. Schematic of electron beam interaction. The maximum resolution obtained in SEM depends on multiple factors, like the electron spot size and interaction volume of the electron beam with the sample. While it cannot provide atomic resolution, some SEMs can achieve resolution below 1 nanometer. Typically, modern full-sized SEMs provide resolution between 1 to 20 nanometers, whereas desktop systems can provide a resolution of 20 nanometers or more.